I'm Jonathan Stevens here today at the Lightwheel booth at GTC 2026, and I'm here with Tao from ADI. And Tao, it's nice to see you.
Likewise.
We're going to talk about what they do at ADI, and we're going to talk about simulation and real to sim and sim to real. So let's start out with what do you guys do at ADI?
Yep, absolutely. So ADI is actually a very old company. Like we have about 60 years of a history, and our main focus is building semiconductor chips. Right, that's where we started, and the analog is our heritage, but it has sustained our portfolio of products till now.
Okay.
And as we kind of going into robotics age, we're coming up with new ideas of how to integrate everything into robots and how to innovate, and especially solving our customer problem and bring new technology into these use cases and unlock them, right? Especially with AI. And that's what we're doing in analog, and what we're trying to innovate is around tactile solutions, dexterity, humanoid, right? It's all upcoming.
Okay.
And we want to focus on real world use cases and unlock them as part of our mission.
Okay, so you had a few key points that I really want to dive into. So you've been around for a long time, so you have a lot of history, but robotics is new. So not everything is what you've learned for semiconductors applies today, so we're kind of reinventing the wheel on some things. And with that, you guys are building tactile sensors. That's like a really hard thing, and the hands manipulation. What is it in tactile sensors that is so critical for what you're doing for your customers?
Yeah, that's a good question. In fact, like tactile sensing, I would say it's not that new. It's new because of like the humanoid, and people are trying to understand, why human can do so many tasks so well, right?
Okay.
How human can generalize, and of course, we use our sense of touch from our hand extensively, and that is what drive like a lot of innovation and interest in putting tactile sensor on robot and see what they unlock. On the other hand, tactile sensor is also new in the sense that it has not hit mass production and mass adoption.
Right.
And so the technology to build really high quality production level kind of industrial grade tactile sensor is not there. And so if we're thinking about like AI, right, that's the new driver for this robotics wave of innovation. And it is important that we need to have a lot of data, and having good tactile sensor that can create that much data that's robust, that's repeatable. These are the critical problems that we face today that we're trying to very hard, like using our 60 years of analog technology and fundamental understanding of the physics to create such a sensor that unlock data collection and scale data.
Okay, so I see, I've shook hands with robots, right? Like the Unitree, and there's not a lot of sensors in those hands, right?
Yep.
And they're able to grasp my hand, not crush it, shake it. Why can't we get away with doing tasks in a warehouse without a tactile sensor?
Yeah, and in fact, people have been doing a lot of automation and robotic tasks without tactile sensor for decades, right? Like that's how robots are deployed in factory. They move, they pre-program to perform a task, mostly like grasp object, like put it somewhere else or manipulate or insert. Those are primarily pre-programmed with very tight tolerance.
Okay.
And so like if we're trying to generalize that to something that is in household or in more kind of small volume, a lot of dynamics happening, it is very hard to kind of pre-program those tasks to accommodate all those kind of variations of size, shape, material, right? And putting them together in a very precise manner like human is very, very hard. And rely on vision, yes, we can do it, but you can probably do it very, very slowly because we need to be very, very careful. But with tactile, and as human, right, we extended use sense of touch to feel where things are and how things put together, and which is the least resistant way to put two pieces of object together so that they can mate well, right? So these are the things that we kind of learn from our experience.
Right. Well, I think about a good analogy is I'm plugging in a cable into the, like back of my computer at home. Everyone has had a computer.
Yeah, like reach to the back of the
right?
computer. Like,
and you don't know it's all in, but you feel when it clicks and when it stops. And then you don't even have to see it. You just know from the sense.
No, like you can even like feel the connector, and then you'd be like, oh, this
there
is
where it is.
And with orientation.
I think a sense is one of those passive senses that we have. The touching that we don't think about, that we use all day, every day when we're manipulating things. And
we only appreciate when we start losing them, like wearing thick gloves and things like that.
Right. I also think about like when you're trying to screw like a nut on a screw, and you start to like, did it catch right? And all those little fine things that a robot needs to learn, right?
Exactly.
And so then you have these great devices that you're building, and we get this high quality tactile sensing data. Then what are we doing with simulation with the Lightwheel component?
Yeah, like simulation is actually very hard on this because we're talking about measuring force, right? And fundamentally, these tactile sensors reflect how the force distribution happened on our finger. And in simulation, like today, like we have amazing simulation, especially on visual appearance. They look great, like look like photorealistic. But when it comes to contact force, there are some challenges, like especially around like accurate capturing the force at the fingertip. Also, even like thinking about contact-rich tasks, which means that we got in contact with a lot of things. The contact interaction, not just between our finger and the object, but also between different objects, start to impact the fidelity of the simulation. Right? And all those contact and interaction needs to be captured accurately so that we can model the whole environment, including all the interactions of deformable and rigid body, in order to get enough data and reflect what the task needs to be, and our AI can faithfully learn and validate its capability in those environments. And that is like very, very challenging today.
Okay, so what we do well at Lightwheel is create sim-ready assets. So again, we're getting those physics, those like the senses when you're touching it, making sure cloth feels and touches like cloth. But like, let's talk about how we get there. You don't start with sim. We all have to start with real sensors. Really
real
touching
objects.
it. We're building a physical measurement factory with arms that are picking up objects and manipulating them. And so having that high, is there like I guess the question hardware is actually a newer thing for me. I come from the software world. Is there like a benchmark for sensing technology, like how well it can sense like a high definition touch versus like a low definition touch? So when you're building these assets, they're like you have to reach a certain amount of tactile definition or fidelity in the sensor before it even will work for
that's a great question, right? Because right now we're talking about simulation within software and interaction with the hardware. Like, what is the interface in between? And what is important is we need to define one that is not just for one thing, but also make it generalizable to all the different objects. So the way that we define it is through the physics. Like, for example, for the physical force that of me touching this table, right? So there are two parts. One is the actual force that's in physical quantity, like in physical unit, like newtons. And the other thing is what is our sensor readout looks like given that physical quantity. The interface between the physical world and the simulation is physical quantity.
Right. Physical quantity.
That is the standard interface that we understand, that we can have a lot of capability to model, and having that understanding of what the simulation tells us physically, and be able to match that with what the measurement that we can do in real world in physical units. And we align them. That is how we see how the real world and the simulation can be aligned.
So to take a physical object, and I'm going to make a sim-ready asset. I want to simulate it in Isaac Sim and Jogo, one of these platforms for doing teleoperations and simulation. I need a very high quality sensor. So I'm not creating something that is low quality, not realizing I just didn't use an appropriate sensor. So we really rely on working with ADI companies like you to make sure that what we're using to generate sim-ready assets is as high quality in the hardware aspect, so we can create the highest quality we can. as a simulation asset.
Yep.
And it
Exactly.
really all starts with you. It all starts with hitting a high quality sensor, because we don't have high quality sensors, we can never achieve it. I can't just use it, like you said, a vision stack to say, okay, well, we know how hard we pulled on that by how it appeared, you know? So that's really important. So everything goes from real to sim. And everyone's been talking about that sim to real gap. So we talked about this earlier before this, is like, everyone's like, how do we solve that? But we really should be starting with the real to sim gap first. And that all starts with quality hardware, doing things in a streamlined, repeatable way as well, so there's not variation just because of the person pulling might pull different.
Or they get different batches of the sensor that perform differently.
Oh, good point. I didn't even think about that. There's so much complexity. So how come I can't just, let's say I'm pulling like an articulated, rigid body, I'm doing a refrigerator door. Why can't I just measure that sense in like the elbow of an arm?
Yeah, you can, absolutely, right?
Those are easy?
Yeah. So there are very like different levels of sensing that we can do.
Okay.
And for large objects, like for more kind of low dimensional, let's call it low dimensional information, like you can use force sensor like at the arm. But when it comes to something that is much like smaller, that requires very fine-grained sensing. For example, if you're putting together a very small gadget, right? Like if say like you disassemble like this watch that has like tiny screw that have like small pieces that you need to fit together. Like that is where kind of high fidelity simulation with high resolution matters, because then you can sense the orientation of the object, you can sense the size, the where things are, and so that when you try to fit them together, like you're relying on this sense of touch to do it.
Well, I think if I'm grabbing, again, I'm thinking of like a nut on a screw, something that I'm assuming anyone watches has done in their life at one point. Even as a kid, you've played around with hardware. So to even know you're gripping the nut correctly, and like you have to make sure you're grabbing the flat edges of the nut there, the hexagon, and so you need to be able to feel that really small.
And if you do it wrong, like you're getting stuck, and you can't really turn.
There's not always a lot of contact area, right? So you do this contact-rich manipulation, but maybe only a very small part of the sensor is actually having to interact with it. So when I was talking about as well, where you have like the resolution, is there like a high HD versus like a standard definition of the text? Is it like on a sensor? Is it graded and like you have, we could say like little areas? How does that? Is it like I'm thinking like you're watching movies and it's like 1080p, 4K, and it's a bunch of pixels. Is that what it is? Like 4 pixels sensors in there?
Yeah, that's one aspect, right? So one aspect is how many like physical, what we call them tactiles. For a tactile sensor on a finger, right? Like there are a lot of metrics that people care about, and something like the density is what we usually use. Like it's kind of similar to video. People say like 1080p or 4K. That is kind of the number of pixels that you have on the screen. Similarly for the finger, we're talking about maybe like over 1,000 points. That's where we see like really high definition of tactile, because human finger usually have like about 1 millimeter of resolution on our fingertip. And for the size of our finger, if we have 1,000 points, that's like roughly or even like a little bit more than human can do. And what is also important is our skin has more than just force sensor, but also something like vibration, temperature. All these are sensing modalities that we introduce to our multimodal tactile sensor, so that we can capture more information, rich information that we can use to perform these robotic tasks. Right. And what you also mentioned earlier is kind of like the nuts and bolts. It's a very interesting concept, because when you think about like threading a nut, right? Like you're operating on the nut, but the nut is constantly making contact with the bolt, and so that the friction and the dynamics and the physics that between the nuts and bolts actually matters as you're doing the operation, more than just in addition to just the finger with the nut, right? So that's where these kind of contact-rich manipulation becomes challenging, like especially in simulation if we can't model that part well enough.
Right. Okay. So I'm having a lot more appreciation. There's like a lot to do with these tactile sensors and getting all that data right. for manipulating, for creating real to sim objects. So the last part is, this is a monumental challenge. Humanoids, any robotics, even just robotic arms manipulating things in a warehouse. And so we need to be moving at a scale that is, I think we've talked to the CEO of Lightwheel. He says, like, we need not to be 100x, we need like a million xing.
Exactly.
We need to scale as fast as far as we can. So what are we doing with you to scale this real to sim aspect of creating similarity assets?
So in my mind, I feel like this is really at the dawn of physical AI, right? Like, we're talking about maybe like 10,000 hours of video that, like, we spend a lot of time like trying to curate, but just comparing to the internet scale of data that people use for these foundation LLMs is tiny.
Right.
And so how do we like scale to that? Like, one of the most important things is definitely simulation, because nothing can scale at the same speed as compute, hence the simulation of the environment.
Right.
And so closing the gap between real and sim and have a validated set of simulation assets that match well with the real world, like, that is the beginning of this scaling curve. Right. And the second thing is about the sensor that we have and it can equip to humanoid hand, to all kind of robotic with time of flight, right? Like, we have time of flight sensor that also has a kind of a high fidelity simulation that we have created. Like, have all these assets available in simulation and have an ecosystem that we can build all these different environments with all these validated assets to represent different tasks and be able to scale the data in that way. I think that is really the critical next step.
Right. The only way we're gonna get to those billions of hours of teleoperations data, sim data, sim-ready assets, all of this, it's not solved with software. It's not solved with just hardware. It's all robotics. It's where what I love, where hardware and software come together and meet the real world, right? And so, not one person's going to solve this problem. No big company here. We're at GTC. We see some of the biggest logos on the planet, and none of them have everything they need to solve this problem. So, like with us, working with you, is you can make sensors at scale to meet that, like you said, really high fidelity spec. We can build warehouses of these arms with high quality sensors, putting real assets in there, creating these environments, then we can do teleops. We're even working on simulating the teleops, where you can tell an LLM agent, I want you to make a grilled cheese sandwich 1,000 different ways, and it'll just come up with 1,000 different trajectories to do it. But it all starts with, it's amazing, like, if you think about it, it all starts with hardware to get it in simulation, and then back from simulation to hardware. And if you fail at one point, any point, you're not going to as close to physics accurate as possible. It's just, you've done a lot of work to get to the point and say, why is my model not working? Why is this robot not able to do anything? So it's all about working with people who don't understand scale, understand sim-ready assets, who've worked in simulation, who've worked in hardware for a long time, to work together to solve this part of the problem too. There's so much more to talk about, but the data gap has to be solved with collaborating with hardware and software together.
Absolutely, and build an ecosystem around it.
Right. It's all infrastructure at this point we're starting to build. We can't have a thriving robotics physical AI community unless that infrastructure is there to be supported on. Think about in the 2000s, we built all this internet, came about, and we laid all this fiber optics and all this infrastructure, and we couldn't have what we have today with all that being laid. And so we're kind of laying that for robotics, right?
That needs to be scaled like in one way or the other. Right? Because otherwise, like, AI is like heavily relying on that, and how we make that happen.
And it'll be very interested with agents, because we're already putting that in the center. What Lightwheel does is there's a lot of manual tasks still. How much can we put automation that doesn't need to be human? Because there's still a lot of things that we still need humans to do in this loop. So it's all about how can we accelerate with scale and speed and quality.
That's a very good point.
Well, Tao, it was great getting to talk to you again.
My pleasure.
I hope someone learned something about it. If there's one key takeaway, like when it comes to all the real to sim to real, like what would you leave people with if you want them to go start learning more about this?
I'd say most important about physical AI is the scale of data. And we are at the point of inflection point, how we can scale that with physically accurate simulation, right? And that is the most important thing, like, in our mind, and enabling that is our top priority.
So if people see this and they want to engage with ADI as well, how can they learn more about you?
Yep, absolutely. Like if you're at GTC, please come to our booth at 3203. Like it's in the Grand
You
Forum.
can look it up if you're here, trust me. Yeah,
absolutely.
But great. Look for Tao, or I'm sure there's plenty of you that you can talk to. Well, it was great catching up with you. And again, we're Lightwheel as well, and we're in booth 1406. So there we go. Hope you have a good show, and thank you for watching.